Alright, so here I'm just kind of doing a motion study on a chain of hand cranked cigar rollers. The ideal here would be that all those hand cranked cigar rollers would be sprocket chain driven by a single motor drive. And just for some fun, I brought in a 6-axis robot arm and was trying to visualize, what can I do with that since I can't get a spool of homogenized tobacco leaf. There's only one company in the United States that sells homogenized tobacco leaf. And the largest company is Russia and China. And the company that sells it here in the United States, they only sell the very large commercial automatic cigar rolling companies. And I can't get a hold of anybody there, probably because you have to have a lot of money to even talk to them in the first place. So, what if I built a 4-foot robotic arm? What could I do with that? Let me pop it in here and see if I can come up with ideals. Well, that's what this little part's about, but I don't think we're going to use a robot arm for this project. So, one thing I thought about doing is simply just making an array of the hand crank machines, but put them on a chain sprocket drive that's PLC controlled. And you push a button, and it starts rolling all 7 of them at one time. So a human being would go and fill all these machines with tobacco. You could do it really fast. Push a button, it starts rolling them, and then you push another button, and the lids will close. All the lids will open, all at the same time. So you could just, run through and pack the machine, boom, 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 just fill everything up, and you could quickly produce a lot of cigar bunches this way with a chain of them. So again, where the hand crank roll is, it would be a single reduction gear drive that would chain drive all of them at one time. Then the pneumatic arm is going to open and close the top at a push of a button. So test the machine out.
Yeah, that looks a lot more flesh, a lot better. Yeah.
So I'm looking at different kind of locking mechanisms for completely round shafts. Not just a keyed shaft. I may use a keyed shaft or a completely round shaft, or a shaft that has a flat face that you put it, insert on and kind of bite down. But a lot of shafts for smaller projects like this are going to be completely round, like your NEMA 23 motors. They usually have a flat face on them or a completely round shaft. So typically when you're dealing with a round shaft, you're going to have a compression hub. Your locking mechanism is pretty much bent on maximum surface area, like getting as much compression around the surface area of the shaft as you possibly can. So a lot of hubs or sprockets or belt drive gear like this, we'll be able to call it a gear, they'll have a little split in the main front of the hub. It's about 1 to 1.5 millimeters split in gap. And you'll have a countersunk hole with the socket head screw that's going to screw into a threaded side. It kind of looks like this. And what you're going to do is you're going to tighten that down, as much as you can, or maybe to a torque spec. And if you have more space, like if you have a longer shaft, you could put 2 of those on there. Then you have keyless friction locking devices. These are called power locks, mecha lock, friction fasteners, keyless bushings, if you will. And these have been used, there's similarities of this that you can also find in concentric nuts for high-speed hydraulic spindles or high-speed spindles on very large CNC machines. But it works a little bit differently. It squeezes in while pushing out. It does both at the same time. So what you're trying to do here is you're maximizing the surface area, and usually these keyless, these keyless locks they'll have a torque spec or a maximum torque spec that you can achieve depending on the size and diameter of the shaft. So as the screws go in, it draws in the back side, and that presses up on the axial surface of the shaft, but it also presses outward, radially. So you're getting both directions against the shaft. You're squeezing the shaft and the sprocket or hub or gear drive. It does both, and you have different kinds. Here you have this wedge type, which is a keyless hub as well. And this is how we can mount to the motor. So when I'm thinking about my design here, I'm really thinking about going a sprocket design to do a chain drive system if I was going to drive multiple cigar rollers. And so that's where surface area really makes a difference. But now we're going to go ahead and jump into getting my PLC box set up and ready. So here I'm going to cut out a power cord socket. Well, not really a socket, I mean a recess. So I'm using a little Dremel here, a little saw that I bought from Harbor Freight, speeding up the video here and reducing the audio, so trying to be nice and easy on your ears. And what I did is I CAD designed this power receptacle, and then I printed a template out, and then I traced it with paper and a pen, and now I'm cutting it out. So here we're going to see if everything fits. Still got a lot of edges I cut out. This PVC was actually way thicker than I had initially thought it was, so I'm having to put in a little bit more work than I first thought I was going to. But boy, that stuff stinks. I mean, you can smell the chemical just burning off that PVC. It was it's pretty noxious smelling stuff, but it went well. You can see here I'm going to do a knockout and a quick test fit. Receptacle drops in, and voila. Alright, so here I've got my CM5 HMI, which is human machine interface screen. It's a touch screen. It connects into a PLC, and it will let me create buttons and meters and things like that. It can read sensors from the PLC itself, but I need to be able to drop it in, and I just need to create myself a general template. So I'm editing the model of the touchscreen that I grabbed off the Automation Direct's website. It's a step file, so it saved me from having to CAD design it myself. And what I'm going to do is I'm going to move it over into the CAD drawing space, so I can print it on the standard 8x11 letter A size, and then I could print it out on my inkjet printer, take some scissors, and cut it out. So here I'm just drawing it out, or I'm dragging it out, and I'm doing a 1:1 scale because I want it to be actual size. So when I print it on my 8x11 paper, I'll have a little template I can cut with scissors once I print this out, and then we'll see if we can get this screen to drop in just like I got the power receptacle to drop in, and we'll jump over to the next video and see how it goes. Alright, so we've got the template set up. We're gonna just kind of check where I want to put it on the box. So I'm not worrying about squaring this up and getting this perfect. I'm just gonna cut this out, gonna find some room in this box where I want to install this, see how it's gonna fit. So normally if this was for a product, not like prototyping or we're trying to learn the Automation Direct PLC software, I take more time on getting this thing exactly centered using calipers and squares. But here I just kind of ballparked it, and I figure it's gonna be slightly off or have a slight tilt after I cut it out, get it installed. But this vibration cutter just made quick and easy work with it. Now the video is sped up, but if you're cutting into a box, let me tell you what, this thing is the most handy thing in the world to cut out of a plastic PVC box. So here I got most of it and popped it through. Just gonna take a razor here, kind of go over the edges, and just get this thing ready to drop the screen in. This was like a $400 screen. This little HMI screen was not cheap, but I wanted a color screen, I wanted their newest unit. I was pairing their Click Plus PLC with this CM5 from Automation Direct. So you have to know this is a human machine interface screen. It communicates to a PLC controller, and you basically control your coils in your PLC that are on and off states, kind of like stored states inside your PLC, and it gives you a quick, easy interface to either read sensors or check, like if a proxy sensor is detecting, it can make something pop up on the screen, or you can touch the screen and like make a motor start and stop. So I'll be putting some buttons in this box as I'm playing around. I'm using this box for a combination to not only learn the Automation Direct PLC, but also for actual product design. So here's the add-on modules for the Click Plus that I bought. This was the CPU 2 version. It's got 2 slots, it's got Bluetooth, and it has Wi-Fi. So I can give it an IP address, and I can literally program it over the air. So here I'm just slotting in the first module. Now this also has pulse train PTO. It's got pulse train high-speed drive, so it can pulse for stepper motors. I'm slipping my mind. PTO, just pulse train output. Jeez. So I bought 2 pulse train output modules to slide in here, and I have extra IOs. Now it doesn't have any analogs. It's just pretty much discrete IOs, on and off stuff, essentially. 24 volt on, 24 volt off. But the reason why I bought this particular PLC is if I want to get an analog module, I don't have to buy a whole new PLC. I could just buy this, I could just buy another module for this PLC, drop in the analog module, and then, start reading analog sensors and anything that has a analog signal to scale inside the PLC. So here I'm using a cheap cheap DIN power supply, 24 volt, and I was given a small little 24 volt Automation Direct power supply by a coworker that's teaching me some of the Click Plus and Automation Direct hardware, and I'm starting to really like the Automation Direct product lines. I mean, they have great software for the CM5. They have great tutorials on using their HMIs and even getting started programming with their PLCs. So, I mean, I do have an Allen Bradley PLC, and I avoid playing with it because the only real way to use it is with the free RS Logix 5000 software. You got to pay for the RS Logix software itself, like the commercial one, and that's not so buggy. The free ones, it makes you want to pull your hair out and pull your skin off and eat it. I mean, it's just disgusting. It uses a huge software install. I got it working, and I got my PLC over the net, connected over the net, and being able to send programs to it. It just makes working with an Allen Bradley just no fun. Where the Click Plus lines they make sense. You got X for your inputs, Y for outputs. It just the input output convention makes plenty of sense. The program software makes plenty of sense, and a lot of people are really talking great about Automation Direct. I am running out of space in this box. I'm looking at other stuff that I still haven't even installed yet. I'm starting to get a little bit frustrated.
The action kind of good.
I need a bigger box.
Yeah, I'm gonna need a bigger box. I just came out with this little video. That's the first thing that hit me is I might need a bigger box. I might be wiring all this stuff for nothing, and that box wasn't cheap. It was like $80 for that box.
Good.
So here I'm just kind of going through and figured I want an indicator light to let me know that the power supply is providing power output. So I've hooked up the fan to kind of draw any heat and things are looking pretty good here. I'm about where I want to be. I'm about to call it a day because I don't want to blow my whole evening on this, but I ended up having to take a lot of trips to like Ace Hardware and Lowe's because I was little screws, little things that I wanted to grab that haven't came in from Amazon. Like I have some momentary switches that come from Amazon. I want to use those to start a motor. So I want to use some switches to start a motor with the Click Plus, just as I get familiar. But yeah, it's crooked. I looked at it. You can look at the screen. You can't see it's too bad. It's not too noticeable in the video, but it's you know, it's put together just to make it work. It just needs to work. You know, I can always spend more time and make a perfect box. Yeah, I just need it to work.
I need a bigger box!